No one alive in the mid-6th century understood why the sun suddenly dimmed. Communities across Europe, Asia, and the Mediterranean watched daylight turn into a pale, cold glow, as if a veil had been pulled across the sky. The familiar warmth that dictated planting seasons, harvests, and daily rhythms vanished almost overnight. What seemed at first like an unusual change in weather became something far more unsettling. Reports from distant regions described the same phenomenon, a mysterious haze that refused to lift, drifting across continents and oceans, untouched by wind or rain. For more than a year, the world lived under a muted sun. But before we jump back in, drop a comment letting us know what time you're tuning in and where you're watching from. We love seeing how far our episodes are reaching. And don't forget to hit that subscribe button. It really helps us keep bringing exciting topics here on the Primal Roots channel. Centuries later, scientists would piece together clues locked in glaciers, tree rings, and volcanic sediments. Only then did the full picture emerge. Ice cores drilled from Greenland and Antarctica revealed thin layers of microscopic volcanic glass, indicating that a massive eruption had occurred somewhere on Earth. Tree rings from Ireland, Scandinavia, North America, and China showed a sudden and severe drop in growth, confirming that temperatures had plunged within months. Something had disrupted the global climate on a scale unmatched in recorded history. Many cultures experienced crop failures, rising hunger, and the collapse of trade networks that once connected distant societies. Historical accounts from Byzantine, Middle Eastern, and Chinese chroniclers described skies that remained hazy through multiple summers. In the Mediterranean, fishermen reported colder seas and dwindling catches. Farmers struggled to coax even the hardiest grains from the soil. Northern regions endured long stretches of snow and frost, deep into what should have been warmer months. People everywhere sensed that they had entered a strange and dangerous era. The conditions felt almost supernatural, yet the cause was entirely geological. Modern studies suggest that not one but possibly two major volcanic eruptions struck the planet in rapid succession. The first, believed to have happened around early 536 CE, launched an enormous plume of ash and sulfate aerosols into the stratosphere. Unlike ordinary volcanic clouds, which settle within days or weeks, material injected into the stratosphere can remain suspended for years, blocking sunlight and cooling the planet. Evidence hints that a second eruption followed sometime between 540 and 541 CE, compounding the already severe climate disruption. Although researchers still debate which volcanoes were responsible, the fingerprints in the ice show that the blasts were powerful enough to trigger what is now considered the coldest decade of the last 2,000 years. Communities that survived by seasonal cycles suddenly faced an unfamiliar world. In northern forests, animals migrated early, while others failed to appear at all. Rivers that normally thawed in spring remained frozen. In East Asia, written records describe persistent fog, unseasonal frost, and harvests so poor that entire regions were forced to ration basic staples. Across the Indian subcontinent, monsoon patterns shifted, bringing erratic rainfall that further strained agriculture. The disruption to food systems was not immediate, but grew steadily as harvest after harvest failed to meet demand. Archaeological findings from villages and early medieval towns show signs of abandonment during this period. Storage pits were left half-empty, tools were buried hastily, and construction projects halted mid-progress. These traces indicate communities struggling to adapt to a world where traditional methods no longer guaranteed survival. In the Eastern Mediterranean, luxury items became rare as long-distance trade faltered. Caravans and merchant ships depended on reliable weather conditions, and the unpredictable climate made journeys riskier, reducing the flow of goods between regions. Researchers studying human remains from this era have noticed rising evidence of malnutrition, especially in coastal and rural populations. Many skeletons bear markers of vitamin deficiencies that develop when diets rely too heavily on limited food sources. Teeth and bone growth patterns in children reveal interruptions consistent with prolonged stress. These biological signatures confirm that the climate shift deeply affected daily life. weakening populations long before pandemics emerged to exploit their vulnerability. The dimmed sunlight also altered ecosystems in ways that would only become fully visible years later. Reduced temperatures shortened growing seasons and shifted vegetation zones. Plants adapted to warm climates retreated, while cold-tolerant species spread into regions where they had rarely thrived. This ecological rearrangement affected wildlife as well. Herbivores changed their migration routes in search of dependable food, and predators followed. Some species became more common, others nearly vanished, and the altered balance rippled through entire environments. Although different societies responded in their own ways, the psychological impact was universal. When the sky refuses to brighten, people search for meaning. Some communities turn to rituals and omens, others to political or religious leaders who claim to understand the crisis. The uncertainty bred fear, but also innovation. Farmers experimented with alternative crops. Craftsmen developed new storage methods to preserve what little food remained. Coastal groups intensified fishing efforts, adapting their techniques to colder and less predictable waters. In many regions, this desperate ingenuity sustained entire populations. Yet the strain accumulated. Food shortages grew more widespread, and weakened immune systems made communities more susceptible to disease. The stage was set for the arrival of plagues that would sweep across continents in the following decades. The world, already destabilized by years of climatic stress, faced a rising tide of crises that historians now recognize as a turning point in global history. Despite the devastation, this period reveals the remarkable adaptability of human societies. Villages rebuilt, even if relocated. New trade routes emerged to replace those lost. Cultural practices evolved to cope with recurring scarcity. The hardships endured during these years left lasting marks on traditions, diets, and even genetic resilience. The era became a silent architect of future civilizations, shaping the conditions from which new technologies and social structures would rise. The shadowed skies of 536 CE were not merely a meteorological anomaly. They were the beginning of a profound transformation. What people witnessed in those years forced communities to understand their dependence on the environment in ways no generation before had experienced. The world grew colder, harsher, and less predictable, yet humanity endured. The memory of those darkened days, preserved in both scientific data and cultural narratives, serves as the opening chapter in a longer story of catastrophe and resilience, a story that continues to shape our species to this day. Across the continents, the dimmed skies of the mid-6th century created more than a climatic anomaly. The colder temperatures, shortened growing seasons, and unpredictable weather began to undermine the foundations of societies that depended entirely on stable agriculture. What started as a veil of haze in the atmosphere soon transformed into a global food crisis so severe that it reshaped migration patterns, political structures, and cultural identities. Communities that had once thrived on fertile land found themselves confronted by barren fields and empty granaries. The delicate balance between environment and civilization tilted abruptly, and the world struggled to regain equilibrium. In regions stretching across northern Europe, farmers watched as once reliable crops withered. Grain that normally reached maturity before autumn failed to grow beyond its early stages. Frosts arrived early and lingered late, locking soil in ice. The timing of planting seasons, preserved for generations through tradition and observation, no longer matched the new reality. Historical accounts describe stretches of cold rain followed by sudden heat, only to return to frigid weather weeks later. Even hardy root vegetables, which often served as a last resort in difficult years, produced smaller and fewer yields. Archaeological sediment layers show spikes in eroded soil, evidence of fields abandoned or plowed repeatedly in desperate attempts to stimulate growth. In the eastern Mediterranean, olive groves and vineyards struggled under conditions they were not adapted to endure. The delicate balance of temperature and sunlight, essential for these crops, was disrupted to the point where entire harvests failed. Written records mention shortages of olive oil and wine, both vital to the economy, trade, and daily rituals of the region. The food system, already strained by political instability and shifting alliances, faced pressures unlike anything experienced in earlier centuries. Coastal communities that had traditionally supplemented their diet with fish encountered unusual migratory patterns in colder waters, where once abundant species became scarce. The situation in Asia followed its own trajectory, but shared the same roots in environmental disruption. The Chinese chronicles of the period describe strange atmospheric phenomena, erratic frost patterns, and the collapse of regional harvests. Rice paddies, highly sensitive to fluctuations in temperature and water supply, suffered dramatic declines. Monsoon irregularities brought either excessive rainfall that drowned crops or prolonged dryness that made irrigation nearly impossible. Entire provinces documented hunger, forcing officials to open emergency granaries that had been saved for particularly harsh years. These reserves, however, emptied faster than they could be replenished. The interconnectedness of early medieval trade meant that a crisis in one region inevitably affected others. Trade routes served as lifelines, carrying grain, dried fish, preserved fruits, and other staples across long distances. When harvests failed simultaneously across multiple regions, these systems could not compensate. Merchant caravans brought fewer goods, and markets that once bustled with activity grew quiet. Excavations of trading hubs from this era show declining material diversity, fewer imported items, and a shift toward locally produced practical goods. Luxury items became rare, an indication that societies were prioritizing survival over wealth accumulation. Famine did not exist in isolation. It created cascading consequences. Malnutrition weakened immunity, making communities far more vulnerable to disease. Stunted growth in children, increased mortality among the elderly, and widespread nutritional deficiencies left populations fragile. Even minor infections, which in better times could be fought off easily, became deadly. The physical toll also altered labor patterns. With fewer healthy workers, fields were left untended, livestock unmanaged, and infrastructure neglected. This feedback loop intensified the crisis, creating conditions in which recovery became increasingly difficult. As food shortages deepened, migration emerged as both a necessity and a survival strategy. Entire families moved southward or toward river valleys where conditions were slightly more favorable. Archaeological remains of temporary settlements, hastily constructed shelters, and abandoned villages map out these movements with surprising clarity. In some regions, these migrations occurred peacefully, with communities integrating into new territories. In others, competition over resources sparked conflict. Groups that had coexisted for centuries suddenly found themselves vying for the same shrinking supply of fertile land and accessible water. The movements of people, animals, and goods during this period reshaped genetic patterns that can still be detected today. Studies of ancient DNA reveal increasing genetic mixing between populations that had previously been relatively isolated. These migrations were not merely physical but cultural. Languages absorbed new words, rituals blended, and survival knowledge passed across groups that might never have interacted under stable conditions. Techniques for preserving food, storing grain, and managing herds were exchanged, adapted, and improved. Despite the hardship, the crisis created opportunities for innovation that would influence future generations. The social fabric of many societies was also strained. Communities accustomed to structured hierarchies and predictable roles experienced a shift in authority. Leaders who could secure food, negotiate with neighboring groups, or adapt strategies to changing conditions gained influence. Conversely, rulers who failed to respond effectively faced dissent or were replaced. This reorganization of power is visible in administrative records that show sudden changes in land ownership, taxation policies, and the redistribution of resources. These adaptations illustrate how famine often acts as a catalyst for political transformation, forcing systems to evolve or collapse. Evidence from bones, seeds, and pollen adds another layer to the story. Shifts in flora indicate that plants typically found at higher altitudes began appearing in lowland areas. This suggests a broader ecological response to cooling temperatures. Similarly, Seed remains from archaeological sites reveal that communities experimented with a wider range of crops, including species not traditionally cultivated in their regions. Some of these attempts failed, but others became new staples, shaping the diets of future societies. The transition was uneven and often temporary, but it shows the lengths to which people went to secure even minimal harvests. Hunger also influenced cultural and spiritual life. Folklore, inscriptions, and ritual artifacts from this period often reference themes of scarcity, protection, and environmental change. Stories passed down through generations describe years when daylight felt diminished, seasons reversed, and people were forced to rely on resilience and ingenuity. These narratives, though shaped by metaphor and memory, echo the scientific evidence of widespread famine. They represent the human attempt to interpret an environmental crisis that lacked any clear explanation. The long-term consequences of this global food collapse were profound. In some regions, population numbers declined sharply, leaving settlements smaller and more dispersed. In others, reduced competition for land after periods of depopulation eventually allowed ecosystems to recover, creating opportunities for renewed agricultural expansion centuries later. But the immediate aftermath set the stage for additional crises. Weakened populations created ideal conditions for pathogens to spread, and the next major catastrophe, the Justinian Plague, would arrive precisely when societies were least prepared to face it. The famine of the mid-6th century is more than a historical footnote. It acted as an accelerator of change, pushing human communities into new territories and forcing them to adapt technologically, socially, and culturally. The global nature of the crisis, confirmed through scientific data and archaeological evidence, demonstrates how interconnected early civilizations already were. A disturbance in the climate radiated outward, influencing decisions, movements, and survival strategies across thousands of miles. Adaptation became a defining pattern, revealing resilience not only in biology but also in shared knowledge and collective effort. In the end, the struggle against hunger reshaped humanity's relationship with the environment. Entire landscapes were redefined as people abandoned failing fields and cultivated new ones. Animal herds moved in response to shifting vegetation, creating different ecological balances that future generations would inherit. The silent records preserved in sediment layers, ice cores, and genetic markers show that this chapter of history was not simply a moment of darkness, but a complex transformation that altered the trajectory of civilizations. The famine wrote itself into the human story with lines that continue to influence the world today. Hunger had already weakened communities across continents when a new threat emerged, one far more silent and lethal than cold or famine. As trade routes reopened slightly and people moved in search of better conditions, something else traveled with them. A microscopic passenger that would change the course of civilization. What began as isolated reports of sudden deaths in port cities soon evolved into one of the deadliest pandemics ever recorded. The pathogen responsible, later known as Yersinia pestis, spread with a speed and intensity that defied the understanding of the time. The world, already destabilized by years of climatic stress, now faced a biological catastrophe of unprecedented scale. The earliest signs of the outbreak appeared around the Red Sea and the eastern Mediterranean. Ships carrying grain, textiles, and livestock also carried fleas and rodents that thrived in warehouses, markets, and densely populated neighborhoods. Once aboard a vessel, these animals moved effortlessly between continents, crossing hundreds of miles faster than any caravan. Human settlements, exhausted from food shortages and weakened immune systems, provided ideal conditions for explosive transmission. Population density, poor sanitation, and limited knowledge of disease vectors allowed the contagion to spread unchecked. Contemporary descriptions offer vivid yet fragmented glimpses into the devastation. Urban centers recorded thousands of deaths each day at the height of the outbreak. Streets filled with bodies awaiting burial. Entire families perished within weeks. Government officials, religious leaders, and medical practitioners were often among the first victims, leaving societies without guidance or authority at a moment when stability was most needed. The psychological impact of these scenes echoed for generations, preserved in letters, inscriptions, and administrative records that documented entire districts emptied of inhabitants. Modern DNA analysis of human remains from mass graves has confirmed the pathogen's identity. Using ancient genomic sequencing, researchers traced its lineage and discovered that the strain responsible for the 6th century pandemic likely originated in Central Asia. Climate fluctuations had affected rodent populations in this region, triggering cycles of expansion and collapse that increased pathogen spillover. When environmental conditions forced animals closer to human settlements, transmission pathways multiplied. Once the bacterium entered trade networks, the spread became inevitable. The scale of mortality varied by region. Some remote villages recorded only small losses, possibly due to isolation or differing ecological conditions. Large urban centers, however, suffered disproportionately. Port cities along the Mediterranean coastline, deeply connected to trade, became epicenters of infection. Archaeological excavations reveal hastily dug burial pits filled with bodies interred, without the traditional rites that typically accompany death. Layers of disturbed soil show repeated cycles of digging over short periods, suggesting waves of mortality that overwhelmed existing infrastructure. The Justinian Plague, as it later came to be known, did more than reduce population numbers. It reshaped economic systems, labor dynamics, and political power. With fewer workers available, wages rose in some regions, giving surviving laborers greater bargaining power. Agricultural estates that once relied on large workforces could no longer sustain themselves, leading to shifts in land ownership and new forms of tenancy. Governments struggled to maintain tax revenues, prompting administrative reforms and, in some cases, territorial contraction. Empires that once projected strength over vast territories found their resources stretched thin as they attempted to manage both disease recovery and external threats. Trade networks suffered dramatic disruptions. Merchants feared transporting goods from infected regions, and many avoided traditional routes altogether. This withdrawal further weakened already fragile economies. Ports that once served as bustling centers of exchange experienced long periods of inactivity. Excavated storage facilities reveal abandoned goods, collapsed structures, and signs of rapid departure, suggesting that people fled cities during outbreaks or succumbed too quickly to manage their belongings. These sites allow modern researchers to track the shifting flow of commerce and understand how the pandemic fractured global connectivity. The biological consequences extended far beyond immediate mortality. Genetic studies of modern human populations indicate that recurring exposure to the plague may have influenced the evolution of certain immune traits. Variants of genes related to inflammatory response and pathogen recognition appear at higher frequencies in areas historically affected by repeated outbreaks. This suggests that survivors passed on traits that improved resistance, altering the genetic landscape over centuries. Although such adaptations increased resilience against specific pathogens, they may have also contributed to higher susceptibility to autoimmune conditions in contemporary populations. A long-term cost of ancient survival. The disease did not disappear after the initial outbreak. Instead, it returned in waves over nearly 2 centuries, sometimes with reduced intensity, other times with renewed force. Each recurrence struck populations still recovering from previous losses, hindering demographic recovery. These cycles created prolonged instability, with communities constantly adapting to a threat they could neither predict nor prevent. Evidence from skeletal remains shows repeated population bottlenecks, indicating that some settlements never regained their original size. Others relocated entirely, seeking safer environments or new opportunities in less affected regions. Cultural responses to the pandemic were complex and multifaceted. Artistic motifs from this era often incorporate symbols associated with protection, purification, and resilience. Religious practices shifted in many societies as people searched for explanations that aligned with their worldviews. Rituals intended to ward off illness became more prominent, while philosophical writings reflected deeper questions about mortality and human fragility. These cultural expressions, though shaped by grief and uncertainty, also demonstrate an enduring drive to create meaning from devastation. The pandemic also influenced technological and architectural developments. With large populations depleted, some cities contracted, consolidating into smaller, more defensible areas. Infrastructure maintenance declined in certain regions, leading to the deterioration of aqueducts, roads, and public buildings. In other places, however, the crisis encouraged innovation. Medical practitioners began documenting symptoms, treatments, and environmental factors more systematically, laying early foundations for epidemiological thinking. Agricultural communities adopted new crop rotations and storage techniques to mitigate future shortages, integrating lessons learned from years of scarcity. One of the most significant outcomes of the plague was its impact on migration. Entire groups moved across landscapes, reshaping cultural boundaries and altering demographic patterns. Some migrations were voluntary, as people sought healthier climates or more stable food supplies. Others were forced, driven by political pressures or the collapse of local economies. These movements contributed to the spread of languages, customs, and technologies, blending traditions and forming new cultural identities. Genetic mixing accelerated, leaving traces detectable in modern populations that reveal the extent of human mobility during this turbulent period. Despite the staggering losses, the pandemic did not extinguish the progress of civilization. Instead, it acted as a powerful selective force, testing the limits of resilience and adaptability. Communities learned to reorganize, redistribute resources, and develop strategies to reduce vulnerability. Over time, these adjustments formed the foundations of renewed growth. When societies eventually stabilized, they emerged with new social structures, altered genetic landscapes, and deeper awareness of the interconnectedness between environment, disease, and human survival. The Justinian Plague stands as one of the most transformative events in human history, not only for its immediate devastation, but for the far-reaching effects that shaped centuries of development. It exposed the fragility of densely connected societies and underscored the importance of environmental and biological factors in shaping the course of civilizations. The lessons embedded in this period, preserved through scientific evidence and cultural memory, continue to inform our understanding of pandemics and resilience. As the world slowly recovered from the grip of disease, the climate continued its unpredictable path. New challenges awaited, linking past catastrophes with future transformations. The next chapter in the story of human endurance would come not from pathogens, but from shifting environments that compelled societies to redefine their relationship with the natural world. The centuries following the great volcanic eruptions and the spread of the Justinian Plague unfolded in a world still struggling to regain balance. The climate oscillated unpredictably, shifting between periods of cooling and warming that altered ecosystems, disrupted rainfall, and reshaped coastlines. Each fluctuation carried consequences that reached far beyond weather patterns, forcing societies to adapt or collapse. The fragile recovery from famine and disease took place in an environment that seemed unwilling to stabilize, and the transformations it triggered can still be traced in landscapes, cultural practices, and genetic lineages across the globe. In large stretches of Eurasia, forests expanded into lands once reserved for agriculture. Cooler temperatures slowed plant growth and reduced crop yields, encouraging communities to move fields to new areas in search of more reliable conditions. Archaeological surveys reveal that settlements once surrounded by open farmland became enclosed by woodland over the span of only a few generations. This regrowth of forests served as both an opportunity and a challenge. Timber became more abundant, allowing for the construction of sturdier homes and defensive structures. But the encroaching vegetation also brought predators closer to human dwellings and made land clearing more labor-intensive. Across the Mediterranean, shifting climate patterns contributed to the decline of long-established urban centers. Water systems that had supported thriving cities became unreliable as rainfall fluctuated. Reservoirs dried or overflowed, aqueducts cracked under the strain of temperature extremes, and cisterns once filled with clear water, accumulated sediment and debris. Excavated remains show evidence of repeated repairs, suggesting that residents fought to maintain infrastructure even as environmental pressures made stability increasingly difficult. Some cities shrank to a fraction of their former size, while others relocated to nearby hills, where fresh water was more dependable. In the eastern steppes of Central Asia, even subtle shifts in precipitation shaped the movement of pastoral groups. Grassland quality determined the health of livestock herds, and periods of drought forced migrations that altered the balance of power among nomadic confederations. New alliances formed, old ones fractured, and trade routes rerouted to accommodate changing realities. These movements brought technology, languages, and cultural practices into contact with distant regions, accelerating the exchange of ideas. The transitions, while often peaceful, sometimes led to conflict, as expanding groups encountered settled communities who had no desire to relinquish fertile land. Further south, monsoon variations influenced the fate of densely populated societies dependent on predictable weather. In parts of South Asia, archaeological evidence points to cycles of abandonment and resettlement linked to erratic rainfall. River courses shifted, altering agricultural zones and changing the locations of trade ports. Sediment layers reveal alternating periods of flooding and drought, each shaping how communities planned irrigation systems and stored food. These fluctuations taught societies to diversify crops and improve water management, strategies that allowed them to endure in the face of environmental uncertainty. Climate-driven transformations were not limited to the Old World. On the other side of the globe, in the Americas, civilizations experienced their own cycles of challenge and adaptation. In Mesoamerica, tree ring records indicate prolonged droughts that placed immense pressure on agricultural systems centered around maize cultivation. Cities that had once flourished faced shortages that forced leaders to reorganize labor, redistribute resources, or initiate large-scale construction projects meant to control water storage. When these efforts failed, some urban centers declined rapidly, leaving behind monumental architecture surrounded by abandoned plazas and overgrown terraces. In the Andean region, unique topography allowed societies to withstand climatic stress through strategies developed over centuries. Terracing, irrigation channels, and crop diversification served as buffers against sharp environmental changes. Yet even these sophisticated systems had limits. When glacier-fed streams diminished or intensified beyond normal ranges, communities were compelled to relocate or shift agricultural zones. High-altitude climate records show temperature swings that affected the growth of tubers and grains, influencing population movements along the mountain slopes. As climates changed, so did the diseases that thrived in different environments. Warmer periods enabled the expansion of mosquito populations, altering the geographical reach of illnesses such as malaria. Cooler intervals reduced insect-borne diseases, but increased respiratory infections, which spread rapidly in crowded urban settings. These epidemiological shifts placed additional pressures on societies still recovering from earlier plagues. Medical knowledge remained limited, but communities gradually learned to recognize seasonal patterns and adapted their behavior accordingly, adjusting travel, trade, and farming practices in response to the changing risks. The cultural impact of these environmental transformations was profound. Stories, myths, and rituals developed around the unpredictability of nature, reflecting both awe and anxiety. Many societies began to incorporate themes of renewal, resilience, and cyclical destruction into their worldview. Ceremonies meant to ensure rainfall, safeguard harvests, or protect communities from disasters became more prominent. Artistic motifs featuring celestial events, storms, floods, and agricultural symbols increased in frequency, demonstrating how intimately people connected environmental change with spiritual meaning. Technological advancements often emerged directly from the need to confront new ecological challenges. Innovations in shipbuilding improved navigation along altered coastlines, allowing for the expansion of trade despite unpredictable weather. Metalworking evolved as society sought more durable tools capable of clearing denser forests or shaping new irrigation channels. Improved construction techniques made homes more resistant to flooding, strong winds, or changing temperatures. Many of these developments, though born out of necessity, later contributed to periods of cultural and economic flourishing. Genetic studies provide another dimension to this era of transformation. As populations moved in response to environmental pressures, they intermingled with groups they would not have encountered under stable conditions. These interactions left detectable signatures in modern DNA, revealing how climate shaped human diversity. Certain genetic variants related to cold tolerance, altitude adaptation, or immune response rose in frequency among groups exposed to specific environmental stresses. These changes did not occur in isolation, but as part of a complex web of migrations that spanned continents and centuries. The environment also played a significant role in determining which political systems endured. Empires that could adapt their administrative structures to new ecological conditions survived longer than those that clung to outdated methods. Some states invested heavily in infrastructure to manage water and distribute food, while others decentralized power to allow local communities greater autonomy and resource management. These strategic decisions often determined the longevity of political authority, showing that environmental flexibility was as important as military or economic strength. Despite the widespread challenges, the story of this period is not solely one of collapse. Many societies demonstrated remarkable resilience, transforming obstacles into catalysts for progress. Communities adapted agricultural practices, rebuilt trade routes, diversified economies, and forged new cultural identities shaped by both heritage and innovation. The environmental pressures of these centuries forced humanity to evolve not only biologically, but technologically and socially, laying foundations for future eras of growth. As the climate gradually shifted once more, new opportunities emerged. Warmer periods reopened high-altitude pastures, expanded growing seasons, and revitalized certain trade corridors. Yet the memory of earlier hardships remained embedded in the collective consciousness. People carried forward the lessons of adaptability, storing surplus grain, monitoring weather cycles more carefully, and maintaining networks of exchange that could provide support during times of scarcity. These strategies reveal a pattern of resilience that would become central to humanity's survival through future crises. The changing sky of this era was more than a backdrop. It was an active force shaping the evolution of civilizations. From the collapse of cities to the rise of new cultural landscapes, environmental shifts influenced every aspect of life, creating a world where adaptability became the defining characteristic of successful societies. The evidence preserved in ice cores, sediments, tree rings, and ancient DNA connects these distant centuries to the present, showing that humanity's relationship with the natural world has always been dynamic, complex, and deeply consequential. The stage was now set for the next major turning point in human history, a period when civilizations would continue to evolve under new environmental pressures and emerging diseases, forging innovations and adaptations that would echo long into the future. The recovery of fragmentary bones from ancient rock layers often raises questions that extend far beyond the specimen itself, prompting reflections on entire ecosystems, climatic pressures, and the subtle interplay between survival and extinction. As the Pleistocene receded and new landscapes formed, the predatory lineages that had once dominated began to shift in response to changing temperatures, dispersal corridors, and the progressive decline of megafaunal populations. Fossils linked to this apex hunter, whether scattered tooth fragments or partial limb elements, help reconstruct a creature that shaped ecological dynamics across vast regions. Each layer of sediment preserves clues about its adaptive strategies, territorial patterns, and evolutionary trajectory as the planet underwent climatic cycles that altered available resources and reshaped migration routes. The intersection between human expansion and apex predator resilience is central to understanding the late Quaternary. Archaeological sites reveal concentrations of stone tools near remains of large herbivores, indicating organized hunts and increasingly complex social structures. These locations often overlap with the historical ranges inferred from fossil distributions of large carnivores, suggesting shared landscapes where competition was inevitable. Studies of cut marks on bones, impact fractures, and burned surfaces help clarify how early communities processed their kills and how carcasses they left behind may have drawn opportunistic predators into closer contact. The resulting encounters influenced the balance of power within these ecosystems, each species testing behavioral limits in an environment defined by scarcity and opportunity. Stable isotope analysis provides a deeper view of prehistoric food webs, revealing dietary specializations and seasonal variations in protein sources. Samples extracted from bones attributed to the ancient predator show a strong bias toward large herbivores, consistent with an animal capable of overpowering prey far heavier than itself. Isotopic signatures also indicate a capacity for scavenging during lean periods, suggesting behavioral flexibility that would have increased survival chances during abrupt climatic downturns. Such versatility supported the predator's persistence across multiple habitats, from subarctic plains to temperate forests, each presenting unique challenges and requiring refined hunting strategies. Environmental DNA recovered from lake sediments adds another dimension to this reconstruction, confirming the presence of plant species that once formed the foundation of herbivore diets. Their distribution patterns track the expansion and contraction of glacial fronts, revealing how prey animals shifted their ranges in response to changing vegetation zones. The apex predator followed these herds, adjusting its territory boundaries as river valleys opened, coastlines reshaped, and grasslands transformed into mosaic habitats of scrub and woodland. These transitions influenced the interpretation of fossil locations, helping to determine whether isolated finds represent long-term occupation zones or short-lived incursions triggered by migratory prey movements. As the Holocene approached, increasing temperatures created extensive wetlands, altering travel corridors and fragmenting regions that were once continuous hunting grounds. This environmental fragmentation may have contributed to reduced gene flow among predator populations, gradually isolating groups until genetic bottlenecks emerged. Evidence for this appears in the reduced diversity of certain bone morphologies, hinting at regional specialization or declining population sizes. Genomic reconstructions based on comparative studies with closely related species support the hypothesis of shrinking genetic pools, although the precise timeline remains debated due to the scarcity of well-preserved samples. Later archaeological layers introduce artifacts that mark significant advancements in human technology, including refined projectile points and more durable hunting tools. These innovations improved effective ranges and increased efficiency, allowing human groups to secure prey with less risk and greater reliability. As hunting techniques matured, competition for game intensified, and the ecological pressure on large predators grew. The diminishing availability of megafaunal species further destabilized the predator's survival strategy. The loss of primary prey sources would have created cascading effects, pushing the species into marginal habitats, where encounters with humans became more frequent and increasingly dangerous. The final stages of the predator's existence are reconstructed from isolated fossils found near ancient lake basins and river terraces, often representing individuals that reached advanced age. Wear patterns on surviving teeth indicate heavy use, possibly reflecting a shift towards smaller, tougher prey in diminished hunting territories. Pathological signs on bone surfaces, including healed fractures and joint inflammation, suggest strenuous lives marked by constant movement and repeated injuries. These details help portray the challenges faced during the species' decline, illustrating how environmental instability, intensified competition, and human expansion collectively eroded the viability of once thriving populations. Despite its disappearance, the predator's ecological legacy persists in the evolutionary adaptations of later carnivores and in the cultural narratives of early human communities. Stories preserved through oral traditions across different continents describe formidable hunters with traits that echo features reconstructed from the fossil record. While these accounts are not scientific evidence, they provide insights into the psychological impact such animals had on early societies. shaping myths and survival strategies in ways that continue to influence cultural memory. The predator, though no longer present, endures as a symbol of ancient landscapes defined by raw competition and the perpetual struggle for survival. Modern research continues to refine this understanding, employing advanced imaging technologies that reveal microstructures within fossilized bones, clarifying growth patterns and lifespans. Data gathered from CT scans and synchrotron imaging uncovers details that were once inaccessible, shedding light on developmental stages, metabolic rates, and stress markers. These discoveries enable scientists to compare the predator's life history with those of modern analogs, strengthening hypotheses about its hunting methods, reproductive strategies, and social behaviors. As models become more accurate, reconstructions of prehistoric ecosystems gain precision, allowing researchers to examine interactions between species with increasing clarity. The global effort to study the predator's biology involves collaborative work across paleontology, archaeology, ecology, and genetics. Each discipline contributes pieces to a complex mosaic, representing tens of thousands of years of evolutionary pressure. Fossils recovered in distant regions, some preserved in frozen ground, others embedded in arid sediment, collectively reveal the vastness of the creature's former habitat. They illustrate how universal the challenges of the Pleistocene were, and how species across continents responded to similar environmental shifts in parallel yet distinct ways. While the species may have vanished, its story underscores broader lessons about resilience and vulnerability. Apex predators serve as keystone organisms, maintaining ecological balance by regulating herbivore populations and preventing unchecked resource depletion. When such predators decline, ecosystems destabilize, often leading to irreversible changes in species composition and habitat structure. Understanding this ancient extinction contributes to modern conservation strategies, offering insights into how contemporary species might respond to rapid environmental transformations. By studying these fossil archives, researchers can anticipate potential outcomes of current climatic trends and develop approaches to mitigate biodiversity loss. The final resonance of this ancient predator lies in its ability to connect modern science with the deep history of life on Earth. Its bones, preserved for millennia beneath layers of sediment, function as time capsules that capture fleeting moments from an era of colossal beasts and shifting ice sheets. Each discovery adds nuance to an ever-evolving narrative, bridging long-extinct ecosystems with the living world. Through these remnants, the past continues to inform the present, reminding humanity of the intricate web of dependencies that sustain life and the fragility of even the most powerful species when confronted with persistent environmental change. Don't forget to subscribe. It really supports the channel and helps us bring you more great stories.